How Alcohol Affects Plant Growth by David Bagdasarian and myself, Andrew Khudyan. In this experiment, my partner David and I tested how different alcohols featuring distinct alcohol levels would affect plant growth when compared to our control group of water. In this experiment, we asked 4 separate questions. Can alcohol fluids grow plants? How does alcohol affect plant growth? Do alcoholic fluids kill plants? And can alcohol be beneficial to plant health? In our hypothesis, we believe that the control group, which received water, will exhibit the most elevated mean heights. After conducting research before and after the experiment, here are the main topics we felt are most imperative to know. When plants absorb alcohol through their roots, severe dehydration is a given and the plants will die. When using a spray, the leaves may get coated with alcohol and could be damaged. Some studies say that alcohol called methanol stimulates plant growth when used correctly, but most studies contradict this idea. Ethanol, like methanol, has been found to stunt plant growth. Rubbing alcohol is usually 70% alcohol, so it needs to be diluted to be used correctly. As with ethanol, too strong of a solution will do more harm than good. Isopropyl alcohol, also known as rubbing alcohol, is most commonly recommended when trying to take care of plants. Isopropyl alcohol can kill mealybugs, aphids, spider mites, thrips, slugs, snails, and whiteflies by melting the protective wax coatings, drying out their soft bodies. Eggs and pupa are most likely to not be affected, so you will need to reapply your solution.
Moving on, we have the procedure. This experiment will compare the average heights of wheatgrass all grown in the same conditions with the use of different types of alcoholic beverages that all differ in alcohol percentage. In addition, the grass will be saturated with its respective beverages 3 times a day with the aid of 4 12-ounce spray bottles to saturate the grasses. Furthermore, the heights of the grass will be recorded every other day until the 14-day growth period of the plants concludes. Moving on, the beverages in which we used were hard seltzer with 5% alcohol, rum with 40% alcohol, isopropyl alcohol with 70% alcohol percentage, and the use of water as the control. Moving to the data of the control. So on day 2, there was no growth. In day 8, there was an average of 5.7 centimeters, and on day 14, there was an average of 9.5 centimeters. Now moving on to the hard seltzer, 5% alcohol. On day 2, there was no growth. On day 8, there was an average of 3.2 centimeters. And on the last day, there was an average of 6.93 centimeters. However, on the next slide, it expresses how there was bacterial growth seen within the growth process, which was a factor to the stunting of the growth of the plants. Moving on to the rum, there was no growth due to the high percentage of alcohol found within the mixture. Furthermore, within the isopropyl alcohol group, there was no growth due to the seeds being dried up by the high percentage of alcohol. As you can see on the before, during, and after slide, you can tell that from the beginning to the end of the experiment, through that 14-day period, that there was significant growth within the control group along with the hard seltzer group. We formulated graphs with the corresponding averages recorded on the last day. Going to our analysis, from the information which we collected, our data supported our hypothesis. As the 14-day period went on, the control group grew the most with an average of 9.5 centimeters grown, followed by the hard seltzer group with an average height of 6.93 centimeters grown, leaving both rum and isopropyl alcohol with 0 centimeters grown. Moving on with the questions in which we asked, we concluded that other alcoholic fluids can indeed grow plants. Additionally, we also found that alcohol can be both beneficial and harmful to plants. Though the experiment was run through smoothly, there were many hindrances in which we encountered. The main problem was within our first trial, where all the plants grown with alcohol had died. We resolved this through creating a mixture of equal parts water with equal parts alcohol. Additionally, the other problems in which we faced within the experiment were the measurements of the growth of the grass, the ability to not kill the plants with the alcohol, and to maintain the growth process while having bacterial growth. Moving on, there were many factors in which we could have incorporated to make a more efficient experimental process. For example, we should have used less alcohol content, such as using a mixture that consists of 99% water and 1% alcohol, which would have allowed for the growth process of the grass to be of heightened efficiency. Additionally, we could have measured the density of grass. With recording the density of grass, we could have had more data to utilize while comparing the groups of grass. And lastly, we could have tested the grass with more groups in order to gain a better insight on the true averages of the grass height.
In conclusion, our experiment aimed to assess the growth of cultivating plants with alternative liquids. We administered a cocktail comprising equal measures of water, hard seltzer, rum, and isopropyl alcohol, each featuring distinct alcohol levels, and examined 3 groups of variation in height. Over a 2-week period, we carefully recorded data every other day and deduced that water is the most effective for plant growth. Nonetheless, hard seltzer yielded intriguing outcomes warranting further research and testing. Our findings may offer valuable insights for future research tasks, exploring the potential benefits and growth patterns of employing alcoholic beverages in plants. Here's our research. Thank you for listening.